Hello and welcome back. We're going to take a look at those basic exponential functions in this section, but we're going to transform them. We're going to move them right and left, up and down, just as we did with the power functions and we did with quadratics and absolute values. All of those functions that we transformed, we're going to do the same thing with exponential functions. Now we just want to start with a basic exponential function, so you have to determine starting point here. When you look at the equation, are we going to start with a growth equation or a decay equation based upon what a is here? So this is a reminder, if a is greater than 1, then we're growing, so it's going to look like this and going through 1. If it's less than 1, then it's going to be decaying. Now a can't be, a always, in both of these cases, a has to be greater than 0 in both of these cases in order for it to work. So in this case it has to be greater than 0. There's no such thing as a negative a to a power. We can have a negative there, but it's going to make it modify it, and that's what we're going to talk about now. So here's my transformations here listed. So the first transformation makes it grow faster or approaches 0 faster. That's when a is a big number or very small number. So an example of that would be something like this. If we had f of x equals 10 to the x power, that's going to grow really fast. So when you draw this graph, it's going to go up very quickly. It's going to be really close to the axis for quite some time, and then all of a sudden it's going to go through 1, and then it's going to shoot up quickly because it's by a factor of 10. Now that's going to happen as well with the less than 1 ones if you had the reciprocal. So the other way it would work is if this was like 1/10. F of x is equal to 1/10, the reciprocal. That's also going to be very quick to rise and very close to the axis because it's a very small number, very close to 0. Very big numbers and very close to 0, they're going to cause it to kind of stretch out. Okay, so that's the first type of transformation. The second type is a reflection on the x-axis. That means we flip it over the x-axis. In that example, we would take our function, and let's say it was negative 2 to the x power. That would just take the original function, which was this one. It kind of looked like this, and it would take it and flip it over the x-axis, so it would go down like this. So it would be a reflection on the x-axis. So that's what would happen if you put a negative in front of this function. Now the negative doesn't get raised to the power, only it gets multiplied by -1. The real thing here is it's -1 times 2 to the x. So that's a distinction you should know. So that's number 2. Number 3 is a reflection on the y-axis, and this is actually what happens between these two transformations. If you reflect on the y, you get from here to here. So this negative exponent, we talked about this in the previous video, this negative means a reciprocal. So it's going to cause that reflection on the y-axis. So when we have f of x equal to 3 to the negative x, that's actually the same as the reflection one, which would be f of x is equal to the reciprocal to the x power. Those are the same. It causes that reflection. So on number 3, when you do that, it causes this reflection, which we normally say 1 goes from growth to decay or vice versa. So if we started with this one and we put a negative exponent on it, it would become 3 to the x because it's the reciprocal. So anything to the negative power is a reciprocal in terms of an exponent. So that's the note there. So that just causes it to flip from growth to decay. All right, number 4 here, we move vertically. We move up and down C units. So on that example, as if we had f of x equals 3 to the x plus 2, that means we moved up 2 units. So our original graph would be here, crossing through 1, and it would go like this. And our next graph would cross through 3. So it would move it up. That means the asymptote here is at 0, would move up to 2. So the asymptote moves up on these vertical things. So our asymptote now is y equals 2 because of this plus 2, and our graph looks like this. So this plus 2 causes a vertical transformation, but it also causes that asymptote to move up. All right, and then the horizontal move, which is number 5, is when we take something and we put it inside the exponent, besides it negative. So we write f of x equals 3 to the x minus 5. That means it moves it right 5 units. Right 5 units. So we don't change the asymptotes or anything when you're graphing it. It's still the same. But this point here, which was 1 here, now gets moved over to 5. 2, 3, 4, 5. So originally your graph looks like this without plotting some points. It looks generally like that. And now it's going to be moved over to 1, 2, 3, 4, 5, and it's going to cross right here. Instead of 1 there, it's going to cross there, and it's going to still look the same, but just be moved over 5 units to the right. Okay, so that's the x minus c in the exponent. Okay, and the last transformation is if we put a value in front of the a to the x, that's going to just change your y-intercept. So if we had f of x equal 4 times 2 to the x power, our original graph would go through 1. So our original graph would go through 1, and this is 2 to the x, so it's growing. But in this case, this graph would be 4 times as much, so we would start at 4 up here, and this one doesn't change the asymptote. It still comes down and it's getting close to the x-axis, and then it goes up faster because it's 4 times as much. So in this one we don't change the asymptote. The asymptote is still the x-axis. The number in front doesn't change the asymptote, whereas on number 4 here, when we moved it up, we didn't really move this up. We multiplied it by 4. So we kind of stretched it vertically. We vertical stretched that one. All right, now we're going to do that on one of these examples. So I picked an example of this, excuse me, to graph. So our first function here, or our parent function on this case, is actually f of x equals 3 to the x power. So we're going to graph that first. So making up some numbers here. So if I do some values for this, for 3 to the x, -3, -2, -1, 0, 1, and 2, and 3. We'll go up to 3. Maybe 3 will be too much. 3 to the third is 27, so that's a little bit too high. 3 to the second is 9. I probably could graph that. 3 to the first is 3. Anything to 0 power is 1. These are the reciprocals. 1/3, 1/9, 1 over 27. All right, so this one is, since it's 3, it gets closer to the axis quicker. 1, 2, 3, 1 over 27. That's really close to the axis. 1/9, that's still really close to the axis. 1/3, that's not even up to a half yet. We go through 1. We go through 3 here. We go through 9, so that's here, and then we can't get to 27 on our graph. So our graph, in this case, our original graph looks like, let's do it in green here. So it still has asymptote at 0. It turns and it goes up pretty quick because of the factor of 3. Okay, so that's our graph. Now, let's start with this value here on this graph. So we're going to reflect on x-axis. We're going to, the +1 moves it left 1 unit, and this is going to be moving our down 4, and we're going to change the asymptote. Alright, so the first thing I would do on this problem is I would draw my new asymptote, since I know it's going to be changed. So 1, 2, 3, 4. I draw my new asymptote right down here at y equals -4. Now I know it's going to be reflected. That means it's going to go this way. Oh, I'm sorry. Yes, it's going to be reflected, so it's going to go downward. I was correct. So we're not going to be able to graph on this graph. We're going to run out of room right away. So, excuse me, we're going to go left 1 unit and down 4 from each one of these points, and it's going to reflect. That means that point's going to change across the axis here. So this point right here at 1, okay, it's going to reflect to here. It's going to move left 1 unit to there, and it's going to move down 4. 1, 2, 3, 4. So it goes through this point right here. So that's this point, the 1. Now let's take this point. It reflects first. So 1, 2, 3, 1, 2, 3. It goes to here on the reflection. Then it moves left 1 unit and down 4. 2, 3, 4. So it goes to there. 1. So reflection is 3 down, 1, 2, 3. So reflects to there, moves over left, and then at 1, 2, 3, 4 down. So that's where that point goes. Okay, this point, same thing, reflects. Okay, we're kind of in the middle here. So reflects to there, moves left 1, and down 4. 1, 2, 3, 4. So it goes to here. So looking at this, I'm going to get a graph that looks like this. And then it turns up through these points. I'm not going to be able to reflect this one and move it in there. It's not going to have a point at 2 because it's going to be so quick that it's not going to have a point. Actually, it's not going to have a point at +1 because if I try to reflect this point right here and go down to here at 9, then I got to move it over and down 4 so it's off the grid. But that's the main graph here. So we do the reflection, we move it left 4. So I just took these points and did that with them on the graph. Reflect, move left and down 4. I drew the asymptote so I knew where it was approaching. So you can see the reflection, you can see that it moved left, and then you can see that it's down 4 units from where it was before. So that's the transformations of a graph.